So, good afternoon.
Mhm.
So, uh, let's discuss about system dynamic. So, this is part of difference equation. Uh, we have discussed the structure of system, right? System thinking, causal loop diagram, and last meeting we discussed about post-process model. Okay, I hope you remember that. The CLD. Okay, and then we put it into simulation like this, right? I think you did that. Okay, so today, this is the last part of this slide. Is about stock flow diagram. Okay, so SFD, stock flow diagram. So this is very interesting. Yeah? This is the one that actually make the several software, okay, dedicated for this purpose. Okay, so our focus is the behavior in the system, right? That growth, fluctuate, and change over time, right? System dynamic. So this is basically difference equation, which is also called functional simulation. Okay. So last time we discussed about causal loop diagram, CLD. CLD is very useful to represent the interdependency and feedback process, right? However, it has limitation. It did not distinguish the type of variable in terms of the level and the rate. Okay. Now, Jay Forrester is the father of system dynamic in 1960s from MIT. Uh, I was fortunate I could converse with him in several occasions in 1990s. Okay. So he the clever things about system dynamic is actually he start to distinguish, okay, in difference equation between two things. One is called the level accumulation, and second is the rate or flow. Okay, so we call this level is stock, and then the rate is actually the flow. Okay. So in this lesson, we will improve our CLD. So you're supposed to have CLD first before you can go into SFD, yeah, stock flow diagram. Okay, so feedback loop is a closed path connecting a sequence of decision. Right? Suppose you have a decision here. Decision is basically a rate. Right? That decision, that kind of decision will control the action. Okay, so if you create a decision, then it will create action, right? So that action will change the level of the system, okay? And then that level of system, okay, will basically influence, that's why it's dot, influence the information about that system, okay? And then based on that information, you create decision. Right? When you make decision, of course you make decision based on information, correct? Right? Whatever information it is, right? So say the payoff matrix, the the probability, right? The utility and so on. So those are information that you use, right? And then based on your decision, okay, you make an action, right? Maybe you build something, you develop something, or you maybe want to destroy something, okay? So that action will influence the level of the system, okay? How much it is. So example, okay? Say you have a system of inventory. Say you have a factory or you have a supermarket, yeah? Or you have a warehouse, whatever it is, your system. Say you have inventory level. Okay? So inventory level, we put it as a rectangular box like this. Okay? Now, what is the action? Of course, the action is to order, right?
Mhm.
So based on if the inventory level is down already, okay, so based on that information, you start to create an ordering decision. Yeah. So you order, oh, how many? Now, this feedback loop is basic structural element in a system, okay, that basically will generate dynamic behavior. Of course, in reality, you will have more than one feedback loop, right? Now, in any feedback loop, in any one loop, okay, you can have two things. Okay, one is called level, okay, and second is called rate. What is rate? Rate is the change. Level is the state. Okay, so this is the theory of J. Forrester, system dynamic. Okay, these two only are sufficient to represent the feedback loop and both are necessary. This is the most important things here. Okay, only two are sufficient and necessary. That means you only need two. Okay, so to to give you understanding, okay, so imagine you have a kind of water like this. So this is the water level, right?
Yes.
Water level, and then what is this? This is the flow rate in, right? And then this is flow rate out, okay? And then you have another level again here, and then this one will go out here, right? So if this is not balanced, say for example, flow rate in is larger than flow rate out, what will happen? If, say for example, you put it in 30 minute, okay? So 30 cubic meter per minute or 30 liter per minute, okay? This one is only 10. What will happen to this level?
Will be higher. And
Correct, very good. Okay, so if the flow in is higher than the flow out, the level will go up, right? Right? If the flow in is actually less than the flow out, the level will go down, right?
Yes.
Oh, that exactly difference equation is about. Oh, you see?
Yeah.
So this level is called state. Okay, so I will write a pen here so that you can understand. This is the X. Okay, say this is Y, right? So what is this? This flow in is the dx. Okay, so we have dx1 here, and this, here you have dx2, okay, which is equal to dy1, right? Here is dy2. Yeah. Or if you, this is in differential, right?
Yeah.
Right? So if you don't like in our system now, you put delta x,
Delta X.
okay, delta x2. So then what is the equation here? Of course, x t plus 1, right, equal to xt, correct, plus
X.
delta x1 minus delta x2. Yeah. Okay. The same thing here, right? So y t plus 1, right, equal to yt plus delta y1 minus delta y2. Yeah. Easy, oh?
Yeah.
Yeah. So now using this, you can create any system. Any system. I'm telling you, any system. This is the amazing part because uh, okay, imagine this X or Y, this one, yeah. This X represent your bank balance, right? Then what is the X? Delta X here is what? Your saving, right? Delta X1 is your saving, right? And then delta X2 is your withdrawal. Ah, correct, right? So,
Yes.
okay, so imagine this level represent, what do you want? Say, parking lot. Yeah? This represent parking lot. Okay, so what is the delta X1 in here?
The delta, the car that go in.
Go in. Okay, what is delta X2 in here? The car that go out.
Oh,
Right. Easy. You can create equation, right? Okay. The same thing with queuing. Oh, any queuing system. Oh, now you start to see. Okay, you can connect with OR here, right? So any queuing system is exactly this, isn't it?
yeah.
Yeah. Yeah, exactly this one. Any queuing system. And queuing its system is actually general enough. So this is even more general than queuing system. Oh, imagine this level represent your faith or your love, right? So what is delta in?
The the that I get
Hmm?
that the things that I receive.
Yeah, the thing that you receive to make your love higher.
The,
You give, not necessarily receive. Yeah, can be give, can be receive. Yeah, the action basically delta x here is the action. Okay, that will increase your faith or your love level. Right? Maybe or going together with your spouse to be. Yeah, right? So how about this one? This is something that you hate, right? That deplete your love level. Yeah. So, oh, now you can model love, you can model faith, isn't it? You can model hope.
yeah.
Wow, you can model anything. Imagine, this is not necessarily that number, not necessarily what that kind of number is not necessarily metrics. Okay, can be utility. Hmm. Yeah. Can be random also, not necessarily deterministic. Do you get it now?
Yeah.
Yeah. Now with this you can, so if this is level of inventory, right? So this is your order, right? This is the one that sold, yeah? Going out, meaning you already sold out. Okay. So now you can model anything. Okay. Now this is an example. So in department store, for example, uh, the level is actually people in store, right? And then people entering, people leaving. Yeah? Say national debt, yeah, and deficit. Okay, so the level is national debt, the inflow is the government revenue, and then the outflow rate is government expenditure. Right? So you can model almost anything. Yeah. So it's up to you to decide what model you want to make, because basically any model will have level and rate. Model, because uh, if it is not dynamic, okay, only have flow, right, or only have level. But remember, the earlier, I said here, both are necessary and sufficient. Now you understand the importance of this, right? Both are necessary and sufficient. So any dynamic system must have stock, okay, or level, okay, and then must have some flow or rate. Clear, yeah?
Yeah.
So now you can imagine to model anything, right?
Yeah.
Now you have become superpower now. Okay, so the level of stock is the state or the condition, okay, of a system at particular time. That's why I put it as xt here. Yeah. Okay, so the height of the water in the pail is the level variable, right? So let's discuss the characteristic of level first. Okay, the present level variable does not depend on the present action. Remember, action mean rate. Okay, but instead is an accumulation or integration. So accumulation means sigma. Integration is the, if you are continuous, you use integration. Okay, if your system is discrete, you just use summation. So when you see a system, last time you create a difference equation, right? Differential equation, right?
Yeah.
And then you integrate, right?
Yeah.
Okay, okay. So in difference equation, you don't need to integrate, you only need to sum. The sum is the same as integration. What is that sum and integration mean? That is actually about level. That is accumulation. Okay, so that the level will increase. So when you see there is a sum there, what do you sum is actually the level, the state value. Okay. Okay. So what is this? The sum. The sum of all the past action within the system. So with what is this past action mean? The rate of flow. Okay. Either flow in or flow out. Okay. So memory or belief is actually a level. So you need to distinguish. When you heard something, when you want to model something, you think, is this level or rate? Okay. Is this level or rate? Example, when you said rich, when you say, oh, that person is rich. Rich mean level or rate?
Level.
Level. Okay. So is when you said someone is rich is actually a level. That means that is actually the state value, the current value, okay, of his or her wealth, right? Go down to become poor again? Yes, if the flow in compared to flow out is much bigger than flow in. Okay?
Yes.
Being rich is not necessarily good things. Depends on the flow in and flow out. Okay? So people think wrongly, they think in terms of the level instead of the flow rate in and rate out. Oh. Okay, so the same thing, memory and belief are level. Okay, level will persist over time. Okay, generate continuity of our attitude and behavior because we have memory and we have belief. So our memory is actually level, not rate. Okay, our belief, if you want to model belief as difference equation or differential equation, so you know that belief is actually a level. Right? Your memory is amount of memory in your brain that is a level, yeah, not rate. Okay, so how do you know this is a level or this is a rate? Here, this is the clue. Okay, level will continue to exist and can be observed even if there is no present activity. Remember, activity, action represent rate. See, I think I have the example. Yeah. So it's not here. Okay. So example. Uh, if you have a factory, right? If you have a factory, for example, so
Mhm.
that factory have reputation, right?
Yes.
Okay. Reputation is level or rate.
Reputation. I guess it's level.
Why?
Because if you don't do well, the reputation can be not good again. Yeah.
Correct. So it's level. Reputation is level, okay, because it continue to exist even if you don't do anything.
Mm.
This moment, okay, if you don't do anything, that reputation does not change.
Yeah.
Correct. If there is no external factor, if you don't do anything, there is no action of external or internal, okay, that level will continue to exist at that level, isn't it? Does not change. So
Yes.
that reputation is a level. Okay, so that is easy to see. Yeah? So second characteristic of level, okay, level characterize the state of system and provide the basis of action. So if you want to do some action, you need to base it on information, right? That information alone is representing as level. So information is a level, not rate.
Mm.
Hmm.
Yeah.
Okay. In fact, I draw that a while ago. Right? Yeah, yeah. Information is a level.
Mm.
This drawing represent the rate. Yeah? This drawing represent the level. Okay, so information is actually level. Okay, okay. So only the value of level variable are needed to fully describe the condition of system. So when you set some system, usually say you are rich, right? Or you are sick. You are sick, right? Or you are rich. So certain description, right?
Mhm.
What we describe is actually the level,
Mm.
right? So the rate variable are not needed to fully describe the system condition because they can be computed from the level. So you can compute the rate from the level. Okay. So now this is important things. Level can only be changed by rate. Okay. Level cannot change other level. Oh, important, yeah. Okay. You cannot change level with other level. So level can only change by rate. So a level is computed by the change due to the rate variable. Okay. The level will alter previous value of the level, right? So remember, what is the equation of level? Xt plus 1 equal xt plus delta x. Huh? Accumulation, isn't it?
Mm. Yeah.
Nah, okay,
Okay.
it's actually sum, right? Or this is integration, so this is accumulation. Oh, this is t, sorry. Okay, clear. Okay, next. Level variable is not directly dependent on other level. So level cannot depend on other level. That's why this line in here, even if you put it into software, okay, it will not become a line like that. It will become dash because this is actually only uh, level cannot go to other level actually. Okay, when you go here is basically copy only or delay. Huh? So any interdependence between two levels must arise because they have in the past been coupled by connecting flow rate. So level, if you want to change this level here, okay, you need to create a flow rate here. Okay. Otherwise it will not change. Okay. Now delay. This is important. Okay, this is connecting to a OR also, right? Delay is actually a level. Okay, delay is actually the source. Level are the source of the delay. Okay, in fact, there are all delays must have some level. So in system dynamic, if you use the software, okay, you have a level delay level 1, delay level 2, delay level 3. That means it's really, when they said delay level 1, mean there is only one level.
Mm.
Okay, level means you have this diagram, 1. Okay, if you say delay level 2, you will see two level. You will have two this rectangle inside. Okay, 3 level delay. Really have 3 level. Okay, so information is actually apparent level, okay, which may differ from the true level. Okay, so this is the basis for decision. So in information is not determined by true condition, which is not instantaneous, okay, not exactly available, but instead by past condition that has been observed. So there is some kind of delay, right? When you get the information today, there is some delay from the actual level.
Mm.
Whatever delay it is, okay, maybe half second, maybe 1 hour, there is a delay, right? So the discrepancy between the true system level and information level, okay, that govern the decision exists in principle. Now, in practice, okay, sometimes we don't distinguish the true and upper level. That's why sometimes we don't put this information like this. So we just put directly from level to action. Okay, what that mean? Meaning there is information embedded inside this level. Okay,
Mm.
but remember, okay, information on itself, there is some delay from the true level of the level. Huh? Uh, but sometimes in practice, so that simplify the computation, okay, so you just say the information is embedded inside that level. So as if you overlay the information inside the level. Okay. Next is about rate, right? Rate is action, decision. Okay. So rate is decision that produce action. Okay. So action or rate will alter the level. Okay. So this is the characteristic of rate. Rate ceases to exist when the action stops. Okay. Unlike level still exists even you have no action, right? But the
Yes.
will stop to exist when the action stops. Clear, yeah?
Mm.
You can distinguish
Okay.
between rate and level, okay? Okay, let's discuss the characteristic of rate, okay? Present rate of flow does not determine the present value of the level variable, but it only tells the rapidity or how fast which the level is changing. Okay, so rate does not equal to delta x is not the same as x. This is what easier to see, right?
Yeah.
So delta x is rate. Okay, x is the level. Clear, yeah? So the rate determines the slope. So when we say delta x here is actually the slope. What is this? The slope means the change. So when we say delta x or delta y, yeah, this is talking about the flow. When we said about the flow, remember, flow means action, okay? Rate, slope, okay? They are the same thing. Yeah? Flow, rate, action, slope, gradient, right? They're all the same thing. That is mean that change. Okay? The level, okay, is the state, the stock. Clear, yeah? Between the two, I hope you can distinguish. So the rate, it does not depend on its own past value nor on the time interval between computation. Okay, the rate on itself does not. No rate of flow can be measured except as an average over a period of time. Yeah. Later you can see the equation. No rate in principle can control another rate. Remember, level cannot be changed by another level. Rate can change level. Yeah? Level can change rate. Rate cannot change other rate. Clear? Okay. Rate cannot change other rate. So, no rate in principle can control another rate without intervening level variable. So, if you want to change the rate, you need to put inside another level so that you can change the rate. So, with this, things become clearer. Okay. How you will, okay. Again, how to distinguish rate from level? Imagine all the activities in the system brought to rest. Okay, only the level variable will remain and observable. Okay, now no rate of flow can be measured except as, oh sorry, this is already finished. Now, example, a tree can stop growing, but the accumulation of the height would be visible, right? The same thing, factory activities can stop, for example, no sales, right? But the number of employees working in progress, the capital equipment, the bank balance, including the intangible things, yeah? Including company reputation, employee morale, okay? Quality of product will measurable or remain. Okay? For example, on Sunday, maybe the factory is closed, right? No activity. Right? So, but again, no activity, right? Mean the level still there, but no rate. Okay, next let's discuss about decision. Okay, decision process here is far broader than human decision making. Okay, so when we say decision in here can be machine decision. So machine can make decision, not just human. System can make decision. Okay, including machine, system, nature can make decision in this case. Okay, so decision process is one that control any system action. So that is easier to see. So it can be human decision, can be subconscious decision that govern biological development, for example, or natural consequence of physical structure. That is also we call it a decision. So the valve and actuator in the chemical plant, okay, automation, that is also we call this decision. Clear, yeah? When we say decision in here mean something that produce action. Okay. So now let's see the characteristic of decision. Okay. Every decision is made within a feedback loop. You see, you have decision, okay, that produce an action there. So decision is based on the available information. You see this? Okay, decision is based on information. So the decision, control, and action that influence a system level, and the new information arise to modify the decision stream. So it's a feedback loop system. Okay.
So is the decision the same with the flow out rate?
Yes. Decision is basically the flow in or flow out.
Oh.
Okay. Can be flow in, can be flow out. Decision. Basically, when we say decision, action, that is rate. We only discuss two things now, rate and level. Right? So I keep talking different things, but actually you in your mind you start to think only two things. Okay, this one is level. Decision in here mean rate.
Yeah.
Okay, information mean level. So a decision process can be part of more than one feedback loop. Okay, so represented as rate of flow. Okay. This is important. A policy recognizes a local goal toward which the decision points strive. Okay. Compare that goal with the apparent system condition, system level, okay, to detect the discrepancy and use this discrepancy to guide action. So, okay, policy will make rate equation. So this is very important. How do you make a rate equation? Right? For practice, you need to do what is called policies. Okay. What is policy? Yeah. Policy statement consists of four things here. Number one, you're supposed to have a goal. Number two, you're supposed to have an observed condition of the system. What is this? Level. Right? Number three, you need to have expression of discrepancy between the goal and the observed condition. Number four, a statement on how action, okay, is to be based on the discrepancy. Okay. I draw this. The goal is the target level. Okay. And then observe current level, for example, this observe of inventory, for example. From the target and the observed current level, you get the discrepancy, isn't it? From the discrepancy, you create flow. Okay, so here, this is other name, yeah. Force, action, policy, flow rate, decision, they are all the same thing. Okay, this is how you will put this into real equation here. Say, I want to do what is called order rate, right? How do you calculate the order rate? The goal, which is the desired inventory, okay, minus with the current observed, the observed current level, which is the inventory. What is this? This is the level, right? And then, okay, multiply or in here, divided by adjusted time. This is just a constant adjustment factor. Okay, so with this system component of policy, you already know how to create equation.
Wait.
Question.
Wait, what is the purpose of the rate equation, sir?
The rate equation,
Yeah, the purpose.
whole system. Okay, if you want to create the whole system, what you will do is you create rate equation. How do you create a rate equation? You think in terms of component of policy, which is that for a while ago.
Okay.
Okay, so system, right? You want to create a system, right? That you think of, right? So
Mhm.
You do in any system. Of course, you said, oh, any system should have a level and should have rate. In reality, the level equation is already clear, right? The level equation is just summation, right? xt equal to xt plus 1 equal to xt plus the rate. So the one that actually creating the one that you need to create is actually not the level equation. The one that you need to create is actually the rate equation. So, and then you ask, okay, I need to create the rate equation, right? So how do you create the rate equation? Easy, four things, okay? This is called policy, component policy. You need to have a target. What is the goal? Right? Second, you need to have the level, which is the current observed current level, right? And then number three, you calculate the discrepancy, the difference, okay, or the ratio between, right? And then based on that, you create action, which is the order rate. Remember, action mean rate. Okay, so when we say stock flow diagram, this is the, I already introduced. So you see this one is the on the right side
Mm.
is actually what you already know, right? This is the what
Mhm.
the CLD, right? Right. So and then you need to change that into stock and flow. Yeah, inflow, outflow, and stock. So that is the diagram. So level is always rectangle like this. Rate is like this. Auxiliary is just a variable. Okay, you can have source and sinks or constant, something like this. And then this is the flow. Okay, so now we can create a system using diagram. Okay, so level, stock, accumulation, okay, or state variable, right? It will change the value by accumulating or integrating the rates. Okay, it will change continuously over time, even when the rate are changing discontinuously, right? The quantity that accumulate over time. So the rate, okay, another name again, rate, decision, action, flow, activity, movement. Okay, all these are representing the change, right? The change in the value of the level. Okay, so the value of the rate is not depend on the previous value of the rate, but depending on the system along the exogenous influence. Yeah? So auxiliary circle like this is just a formula. Okay, any formula. Okay, so it can be internal, can be exogenous. And this is sometimes outside the system, source and sink represent something outside the boundary of the model. Okay, so this is the simplest model. You see, I have a constant flow. This is the level, and then because the rate is constant R, right? Then I have a equation like this. So, and then if you simulate, you will get that this way. Okay, there is no feedback in it. Okay, this is a linear level. Say for example, R is here is 0.2, right? So then it will accumulate over time linearly. Okay. Now if you have causal loop diagram like this, see this is right and left. Okay. So positive feedback loop, right? Okay. Then how do you put it into SFT? So you just put it this way, the same. Okay. This is the rate, this is the level. Okay. So then you put that way. From the level, it will go back to the rate. From the rate, go to the level. Okay. So because it's level accumulation, right? So then you need to have initial condition. Okay. 1, for example. Okay. And then the rate, if for example, depend on the level. So 0.1 times the level. So
Mm.
what is the equation of the level here? Can you see this? This is the equation of the level. Sorry, this one. This is the equation of the level. This is the equation of the rate. Yeah. Okay. So I hope this is clear.
Yeah.
So can you see from causal loop diagram CLD, you can get the SFT. Okay.
Mm,
So yeah. Okay.
okay.
Again here, birth and population. Again, this is CLD, right? The causal loop diagram. Okay. Last meeting we discussed this, right? And then when you put this into SFD, you will get like this.
Mm.
And then when you put it into equation, you will get this kind of diagram. Okay. So this is an example of SFD with negative feedback loop. Yeah? So you see here, this is positive in here and the negative there. So multiply, you get negative, right? Correct? So the equation, you see, the equation here is negative. Okay, so it will influence the rate negatively. So you will see it will go down, okay, to a certain level. Okay. This. Last meeting, you calculate the post process. You create the causal loop diagram. I even give you a assignment for that, right? I did not check whether you are making it or not. Right. Now, the next step, okay, to create a equation, to create a model is actually, first you do causal loop diagram. After that, you create the SFD, stock flow diagram. Okay. From the stock flow diagram, you create the equation. Because the equation is very clear. Okay. The level equation is very clear and the rate is the one that you set. Here, the rate equation is very simple. Yeah. Can you see? The rate equation depend on the level. And the level equation does not change, it's always the same. It's just accumulation. Here I have two rate, yeah? Birth rate and death rate with one level. Right? This is the CLD. Okay. This is the level. This is the SFT, right? So can you see? This is the flow in, this is flow out. So how you will put that into equation? This is what is this? P T plus dt equal P T plus something something. What is this? This is level equation. Remember, level equation is always accumulation. Okay? And then what you need to design is actually the rate equation here. P, T, and dt. Of course, the rate is depending on the level. Yeah? So say I just multiply by a constant.
Okay.
Okay, easy, yeah. So with that, you can actually simulate anything. Right? Okay, so here, okay, this is the CLD, okay, and this is the SFD, and this is the equation, and this is the result. Okay. So, can you see? Now we have two levels, yeah? Children depend on the number of birth, right? Okay, and then this one we create a new rate because remember level cannot influence other level, right? Directly.
Yes.
So we need to have a rate here. So let's say what is the rate name? Okay, children maturing. Okay, so the children become mature now become adult. Okay, so this is the rate. So say the rate is actually 0.03 times the number of children. Okay, so here, this is the metaphor, right? In the bathtub, and then this is the stock flow diagram. Okay, and then if you use integral, you use this stock equal to inflow minus outflow times ds plus the stock zero integral, right? Right. So and then from here you can differential equation here.
Mm.
You can create anything, okay? Anything real, any model, anything. Okay.
Oh.
So what I'm teaching you here is actually how to model, isn't it? Do you realize?
Yeah.
Okay. Now, uh,
Yes.
yes. If you use continuous equation, okay, you use differential equation, okay, and then if you want to put it into computer, okay, you need to use integration, right? So go to my website. I have a example of Rungkutta, yeah, Rungkutta 2, Rungkutta 3, Rungkutta 4, or Euler equation that is using integration, okay. If you use discrete, that is simpler. Okay, so that is called Euler method. This one, you see? Can you see the difference? It's exactly the same. Okay, except dt now become one. Dt now become one. Okay, this is continuous system using dt. Okay. If you use discrete equation, you will have t plus one. Easy. Okay, so yeah, I hope that is the this is just a summary. You can read by yourself. Okay, so eventually we know how to model, and today, okay, I want you to practice. I put a new slide last night there in Lentera. Okay, I want you to practice this. Practice system dynamic. Okay, so just three practice. Actually, several here, but I will just show you first, and then you can practice later. Yeah? So let's practice to create what is called first order positive feedback loop, first order negative feedback loop, and then I will give you also second order, yeah, negative feedback loop. Yeah. Okay. So let's say you want to create a first order positive feedback loop. Okay. Say we will model a growth in sales force. Okay. You will calculate using Excel. My favorite. Okay. And then you will plot. Yeah. Okay. So here it is. A new salesman are located and trained by the existing salesman. Okay. The larger sales force, the more men there are who can train new salesmen, right? So then what we do here, we said it's SHR, salesman hiring rate, equal to the number of salesmen divided by SDT. What is this? Sales doubling time. Okay. So if you look at this, what is this actually? This is a rate equation. Yeah. And you see, SHR, R in here represents rate.
Mm.
So what is this S? S is,
The number of salesmen.
Yeah. What is this? Rate or level?
Oh, the rate.
No.
Wait. Oh, the
Salesman
level.
level. Yeah. Salesman is level. How do you know? Easy. You see this. Rate is always something divided by time.
Mhm.
Yeah. If this is a rate, this is something in here man divided by time. Yeah. If the unit is actually only man here, that means this is only uh, level.
Okay.
Always have initial value. Huh? Don't forget, level always have initial value. Okay. Any other things here represent the uh, just constant. Okay. So SDT here is just constant. Okay. So now the question is find the number of salesmen over time until week 300. Yeah, and then increase every 20. Right. This one. Use 20 weeks. So then we put this into spreadsheet. Okay. Remember the time is every 20, so I increase here 20, 20, 20 until 300. So this is just increasing linearly. Okay. And then initially you have 6 in here, right? And then this is the rate. Okay. How do you get the how do you calculate the rate? The rate is calculated using that equation that we created. Is R equal to S divided by SDT. SDT is constant, so you keep that, right? So if you know the constant SDT and then you know the sales, you can get the sales hiring rate. And then, okay, the change, okay, in salesman, you can calculate also, right? Okay, because you know the rate, you can calculate the change, right? Multiply, right? And then, okay, what you will get, you add to the salesman, then you accumulate. Yeah? So you copy down here. Okay, and then from there you can calculate the number of salesmen. Okay, is actually exponential. So what is this? Positive feedback loop. Yeah? Okay, after this you practice. Yeah, so I'm just explaining first all. Okay,
Okay.
okay. So how do you calculate here? This is the formula. Okay, the change
Mhm.
man equal to the time period, so every 2020 multiply by the okay salesman hiring rate, yeah, T minus T. Okay, so the salesman itself, what is this? This is the level equation, right? So you see always accumulation, yeah. T plus DT equal to salesman T plus the change. That one. This is the change. Okay, and then the salesman hiring rate is the salesman divided by sales doubling time. Okay, this is the one that we gave a while ago. Yeah? This one, right? Clear, yeah? So using that three equation, you can get the spreadsheet, yeah? Clear?
Okay.
Okay. Okay. So in the past, I'm using PowerSim because last time was free, but now it's not free anymore. So you can download FanSim. I think still free.
Fancy.
FanSim. Yeah, you just search FanSim, or you can download for PowerSim, but they can only give you chance to use it for 6 months.
Mm.
Okay. Okay. So using PowerSim or FanSim, you can just drag and drop all this drawing, and then you connect. Very nice. Okay. So and then you can just drop, and then you put click, double click. You put the equation here. Okay, the doubling time, and then you can get all this drawing. Or Look, if you don't want to use this expensive software, right? So you can just use Excel, okay? So this is the formula that I give you. Anyway, you get exactly the same result, okay? The only difference is the GUI, you know. In Excel, you don't need, you cannot drag and drop like that, okay? So it's just convenient, okay, yeah? So, okay, next is the first order negative feedback loop. Okay, so again, we will model a real world problem of inventory of a warehouse. Okay, so I will give you the model. Okay, you need to solve the simulation using Excel, yeah, by plotting the variable versus time. Here, this is the model. This is exactly the same model that I mentioned a while ago, right? The order rate is equal to the policy. This is based on the variable, right? So what is the desired inventory? This is the target, okay? And then minus the inventory, yeah, number of units. So what is this? This is the level, right? Divided by a constant. Yeah, adjustment time here is a constant. So now I have this rate equation, right? This is order rate. So this is rate equation. Okay. Again, you use the period of 2 weeks, the 30 until 24. Okay. So here, every 2 you increase. Okay. And then you need to calculate the change in inventory, CI, the inventory unit, okay, the inventory error, and then the order rate. Yeah. So you can put this as your input initially. And here is the formula. Okay. So if you want to calculate the inventory error, i.e. equal to DI, what is this? The desired inventory minus I. Yeah. What is the inventory? The inventory is the level equation. You see that? Accumulation. Can you see? Right? The accumulation. Yeah. And then this is the rate. And then this is the order rate. It's just based on that equation that given a while ago. Okay. So then you can calculate the change in inventory is just the difference in the inventory. Okay. Using that, this formula, again, you can calculate all this table. Okay. Again, if you use Power Sim or FanSim, again, you can just drag and drop and get all of this drawing. Yeah. Exactly the same result anyway if you use Excel. Okay. The last one, okay, is this. Now, what happens if you have second order? Okay. Look, in system dynamic, first order mean one level. Second order mean you have two level. Third order mean you have three level. Easy?
Yeah, easy.
Easy, easy. Okay. So the order is just the number of level. Okay. So because this is second order, the behavior will change, oscillate. Yeah, will oscillate. Okay. So what is this? So this is inventory with a delay. Okay. Again, I'll give you the model. Right? Because you have two level, you need to have two rate. Right? At least. Okay. And then you will plot. Okay. Yeah. Model 1, model 2. Yeah. I have two rate here. What is this? This is the ordering rate a while ago, right? The same, exactly the same as a while ago. Now you have receiving rate. Receiving rate equal to good in order. What is this? This is the unit. Yeah? This is unit per week. That is mean rate. This is unit. That means what? Level. Yeah? This is level. And level always have something value. So you know GO is a level. Okay. Based on the unit you will know. And then DO here is just a constant. Okay, the constant is that. Okay, so there is a delay between ordering goods and receiving them into the inventory. Okay, so let's plot this until 100 weeks. Okay, so here is the columns. Yeah? Okay, so we have time every 2 weeks, right? And this is the one that we already calculated a while ago. right? The change inventory unit you already calculate. And then this is the new things. Yeah. So these new things, I put the equation here. Here. Okay, this is the equation. So you can calculate the desired inventory minus the inventory, so inventory error. And what is this in here? This is the level equation, right? You see this is accumulation. The same thing with GO here. GO is the level equation, yeah, because this is accumulation. Okay, okay. And these are the two rate equation that you put in. Okay, and then change in inventory is just the difference. Okay, and then change in order code is just the difference also. Okay. Now you see here we can create the say in the software, you will see the behavior is actually oscillate like this. Of course, you will be able to calculate using Excel, and it will also plot oscillate, yeah? Something like this. See? Okay, with this, you practice, yeah. And then if you have any problem, I'm here.
So I make the three of them.
Three of them one by one. Yeah? Okay. And if you have any problem, you just tell me. You,
This one is for
okay.
the first order.
First one, right? Very
Representative.
good. Excellent. Right, so this is exactly the same as in the no.
Uh, no.
No?
Wait. Wait.
0.12
I guess.
is correct. 8.0.7, yeah. Why not?
Is it?
100.
Is it correct?
Yeah, yeah. Wait.
No. I guess no.
Is
Only
correct. Until the second row is
the
correct. And then, oh, what happened to the third row? Why? Is that
uh,
the second row is correct, and then you just copy that down.
yeah.
And why
But
is it different? Wait a minute.
Five and two. It should be correct, right? I just
Hmm.
copy.
Let me see.
Until this one is correct.
The second is, oh, you multiply by dt. The third one is, I think, how do you multiply that? 2.4,
Which one?
the 2.4 there. What is d, d, d3 multiplied by a4? What is a4? Ah,
A4 is the
not a4. Multiply by dt. The dt is 20, that one. Correct.
also only 20.
Yes, because okay, you put in the beginning dt. You can set dt.
Which one?
Example, I give you like this. I will show you. I will stop your sharing a little bit.
Okay.
Okay. So here I put the parameter here.
Mm.
Can you see? I put the parameter. So doubling time 50, right? So I put name here, doubling time. Okay. So and then this one initial sales for 6, right? And then DT, right? So this one you need to input. So let me put it as below so that I know this is an input. Oh, there. Okay. And then from there, this one is multiplied by dt. Yeah. That's why this is correct, but the difference is this is dt. Okay. So the rest is the same, right? This is just summation. This is just C4 divided by doubling time. Is it the same as the result now?
Wait, let me try. Mm,
Yeah. This
mm.
hiring rate is a rate, okay, rate equation. It is given, right? This is practically you just put into the formula, right? So, and this is level. You see, level is just accumulation. You see, level is just of the previous level plus the change. Okay.
No.
Okay. So the only things that you are given is actually only this one, the equation of its salesman hiring rate, right? And then the rest is actually must be exactly the same. So this is level. Level is previous level plus the change. Okay. Now the change is depend on the salesman hiring rate. You see. Okay. In this case, multiply by dt.
So DT
dt in this case 20, right? Every 20. So this is still discrete, but instead of adding 1, I add 20. It's the same.
no,
Right?
20.
Yes.
So it's 1.
Now your turn to.
No, it's the same. Yeah.
Yeah. Okay. Very good. So,
Okay.
okay. Now you can go to the second. Okay. That is negative.
So okay, I will negative one.
So similar to the first one, you also create the uh, parameter. Okay. So
Can I share
dt.
my screen?
Yeah. Yeah.
Because I'm using this for the
Mm-mm. So 1000.
wait.
Inventory
Which one is
is, yeah, inventory is just uh, the earlier plus the period. Yeah.
the very
Yeah.
And
Yeah, multiply by the order.
wait,
The,
this one or the
yeah,
previous
yeah, 1000. The earlier. You cannot
earlier.
put in the same. Yes.
So this one, it is in the inventory. So it is in the inventory. Should be the inventory. This one, and then
The change inventory is just minus, right?
minus the
Yeah.
minus this one. Right? Minus the
So that one is the inventory minus the 3000 minus 1000. Yeah.
so
Mm, correct. Then copy. Yeah. Is that the same? No. What happened? Something is wrong with. Something is still wrong. Why become instead of small? Why become 2400? Okay. Let's see uh, the second time 2. 3000. How do you get the 3000?
yeah.
Oh, that one. Multiply by the period, right? The DT. Multiply by DT.
Oh yeah.
The DT. Ah, okay. Okay. Very good.
Okay. Mm.
Yep. Very good. Okay, excellent. Okay, good. And now you get make the third. Yeah? The third one is
It's similar, right?
similar, exactly similar. Yeah? You just one more level actually. Okay.
One more left. Oh,
Yeah.
okay, let me just make it now.
I just copy that if you want.
Copy. Oh,
Copy the first order and then make it the second order.
so which one?
Inventory,
The
yeah, the change of inventory does not change, right?
okay. So copy.
I mean, copy sheet if you want.
Oh yeah. Okay. So, mm,
Copy, yeah. Create copy.
okay, this one.
Yeah, now you just change the name to second order.
Second order is negative. So OR.
Yeah, inventory error still the same, order rate still the same, right? Now you have additional, yeah, you have additional uh, change of include, change include on order unit, and then uh, good on order unit (GO), and then the receiving rate. Okay? So you add several more columns.
Inventory unit. So error. Okay. So I know this one.
I think you have another class. It's okay.
No, it's okay. Usually
Oh,
the next class start with yeah.
oh okay.
Yeah, because the lecturer also from Australia, yeah,
Ah,
Aussie,
I
yeah.
see.
So that's why he will be late.
I see.
So the unit is in it's
You can read the formula in the slide, right?
yeah.
Make it, wow, very good.
The good thing. So this one what's the order of this one? What's the order?
I think you need to put parentheses.
Oh yeah. Wait. So the
Why you divide by 80? GO, you don't need to divide by 80.
oh, so just this one.
Yes.
The same way.
Change in
Tentang dulu order.
put in order
This one.
earlier.
Terus ini.
One is oh, you did not make the receiving yet. Receiving rate. That one is actually,
Oh,
yeah, that one is actually receiving rate minus the order rate, right?
so okay, so
So you need to
this
create the receiving rate first. Yeah, the receiving rate is just based on the formula given.
receiving minus
Receiving rate is just
um,
good GO, the good in order unit, divided by the delay.
The delay is 10, right?
The delay order is parameter. So 10 weeks. Or you add one more parameter. Okay.
Oh, yeah. Delay.
10. It's sometimes useful if you can put the unit, no? The unit
Oh, okay.
goes
I will put it.
later.
And then so this one. The good unit. So this one
Put in order
plus
unit
and then
earlier plus
times
the period multiplied by uh, parentheses, yeah, in parentheses,
times
yeah, the order rate minus receiving rate. Oh,
oh
earlier, not in the same line. Usually it should be earlier, one earlier. Exactly the same, but yeah, that one plus
okay, times
apply. Okay,
this one.
yeah, order rate minus receiving rate. Okay, close. Okay, good. Something still missing. I don't know what is the missing part there. Infant
Things
order is correct. The change in order is 100, 800. Something is still wrong. Can I see the change? Why the change? The change in good order, yeah. Oh, actually correct. Okay. Yes, correct.
where why is it?
The change is correct, but the result is incorrect. Um,
Hmm,
where is the problem? Until the second row is correct, but the third row is incorrect. Something is wrong.
yeah, this one is incorrect. Right?
Yeah. Why? Maybe the DT again.
The thing
Yeah.
this one is the dating
Yeah, yeah, yeah. So what? Why is different here? Debugging. Receiving rate. Receiving rate supposed to be 1000, 1001. Oh, yeah, the next row is incorrect. I don't know why. Delay order is correct. 10. Adjustment time, order rate. Order rate is no change, right? Inventory. The inventory is desired inventory minus, correct? Oh, wait. What is the inventory? Oh, that one. That is the different. The inventory error. What is the inventory error?
The inventory error is one.
Oh, that one is correct. Inventory minus correct. What?
Let
I don't know. What make it different?
wait, wait, is also different, I think. Yeah. The order rate.
Change in inventory. Change
Hmm,
2000.
no, the order rate. Hmm,
Wait, maybe the parameter. Parameter is 1000, 6000, 510. Oh, initial code is 10,000, correct? Yeah, correct. Okay. Oh, what? Why different?
uh, let me check it. Time, time is 40, and then this one, the change in inventory. Would be correct.
What make it different? 2000, 2000. Change in inventory unit. It's supposed to be 2000 and then 2000 again. But
Yeah, this one.
become 1, 2. The formula is correct. The inventory unit is incorrect.
So this, inventory.
That is correct. The formula is correct. T is the period, right? The TT, right?
Yeah, the doubling time.
Yes, yes. Hmm?
Two, this one, two, one, two, three. Yeah, it's
Then change in code. Change in code is just minus, right? Between the two consecutive.
but the inventory unit in your slide, it is 5,000.
Oh, in my
Yeah,
computation, I got 5,000.
yeah, yours is 5,000.
Yeah. We can use ano. You can use what do you call this? Formula trace precedent, trace dependent. In formulas, in the menu, formulas.
Menu, yes.
There, trace precedent. Okay. There, you click that. There. So that is, you can see that that is depending on the tree. The tree is correct, right?
Yeah,
600 and then 2. What is that again? Inventory unit. Oh, that one is,
in your slide, it should be 5,000. It means we only like off 800, right? To be 5,000. Do we need to count this also?
the
No.
B9 in my computation become 2000. Yours is 1200.
Yeah. Because the change is this one, right? This one minus this one. It's
The change,
1,200.
eh?
But the inventory unit
Ah,
for the
oh,
time,
because, okay. Because the change is 5,000 in my case, right?
yeah.
Yeah, okay. So the inventory unit is the problem, but the formula is correct.
How did you get the 5,000?
Okay, okay. I will show my slide, my Excel, and then you check.
Okay.
Okay, I will share my screen, then you tell me. Okay. So which weight should I go?
Mm, the 5,000 first. I
Five
want to
thousand.
check
Yeah.
it.
This is
Mm,
on the previous one plus the period multiplied by receiving rate. Is that correct?
multiply by
The receiving rate of the
receiving.
previous.
Oh, I multiply by the order rate. Yeah.
Okay, okay. Should be that.
Mm,
Okay, that is the one that explain.
okay. Yes.
Okay, if
Okay.
you change that and then go down, copy down.
Mm, Since this.
Okay, because you are using the first one, like now
Mm,
we change that a little bit, right? The inventory is changed because now before it was based on order rate. Now we base it on receiving rate.
first,
So you get 5,000.
yeah, it's no. Yeah,
So
that is
all
the
correct now.
problem.
Yeah. And
Yeah,
yeah.
okay.
Okay. So this is what I want to show you. The fluctuation. Okay. The fluctuation of the inventory. This one.
Mm-hmm.
Okay. So you see, say you are working in the factory or in the supermarket or any warehouse or something. Sometimes you wonder, right? Why, if you plot the inventory, why my inventory is up and down,
Mm-hmm.
right? Why my inventory is up and down? Oh, so that one mean you have a second order system,
Oh, okay.
Okay, so sometimes you wonder, right? Why? Oh,
Mm,
that is the cause of the delay.
okay.
The existence of the delay will create the up and down. Okay, that's why you see last time, like the oil price. You see, the oil price was reached negative, right? Last time during the pandemic.
Yes.
Yeah, remember that, right? And then now it's like 100 again. So why is that? Because there is a delay. Yeah.
Mm-hmm.
The, there is a delay. So then their inventory, okay, cannot cope with that. The ordering rate and receiving rate. That's why the inventory become up and down, and then at the result, you will see the price is also changed because of that. So
Oh,
interesting, right?
yeah.
So initially, maybe many people, okay, especially if they don't learn this, they will think, I did not order it, I just do it normally, regularly, right? You see, this is all regular. You see that, okay? Yeah, there is no random, right? In this case, there is no random, right? Right.
Yeah.
But why without random, the inventory is still up and down? Okay. So many people have a problem this in industry, right? Especially in industry, inventory level is very important, right? Because if the fluctuation is very big, reach to zero, you have no inventory, your factory cannot work. Same
Mm-hmm.
to produce, or your factory cannot work, right? So inventory level is also very important here. Then you can start to change the parameter here, okay? This parameter, so that the uh, fluctuation reduce. Okay, so you can play in these numbers here. So you try, for example, this is 5. Oh, see, the fluctuation is so if you put one, oh, see, not so much fluctuation. If I put 100 here, wow, the fluctuation is much bigger, up to negative, right? So, so the delay, okay, the delay in ordering matters so much to the system. Can you see? Yeah. So I hope this is a useful application for based on simple difference equation, right? Very simple. Differential equation that you need to integral, okay? Now we use discrete dynamical system, yeah, this difference equation, and then now you can model almost anything, you know. Okay, as long as you know this is rate, this is level, okay, and then once you know this is rate, so you model the rate. Okay, how you model the rate? Again, I explained earlier, right? You use policy variables, policy components, okay? The desire, right? And then you get the discrepancy, okay? And then you will know the equation, yeah, divided by constant. Okay, so with this, can you improve your model that you do your assignments, a mini project that you want? So try to make it into
Oh yeah.
okay computation like this. Yeah, it's up to you. You want to pick it
Okay.
first order, second order is up to you, or third order if you want to challenge yourself. Okay, and
Okay, sir.
you can also draw the stock flow diagram if you want. Okay, thank
Okay.
you for today.
Okay.
Yeah.
Thank you, sir.
Bye. I'll see you tomorrow.